Welcome everyone, welcome back. I hope that you got your tea or coffee, wherever you're into. So we learned how to perform mutations. We learned how to perform queries. We talked about fragments. So the fragments being those containers for fields, which allow you to abstract or encapsulate concern really abstract stuff to make sure that there is a less noise inside your queries. But again, you should be restraining yourself. I know it may be tempting really to create those abstractions as soon as possible, but you should really be restraining yourself because, as I said, you will end up with GraphQL that really does rest because it pulls every possible type. So what we'll do now, as per our agenda, is go to, with the type generation, we'll go to integrating or interacting with cache. Because cache contains, I would say, a treasure trove of data, really. Just think of all the queries that you do, all the requests, and Apollo manages that for you. That's pretty nice. So the goal here of this exercise is to have this list of messages where I can type a message and make sure that the UI is updated. Well, we'll not be able to update it automatically. We'll have to employ some effort, and you will see why when I explain things. But the goal is here to write a message and make sure that we are not refetching the messages, but we are just pushing the data that we just received from the backend into the cache. And we will be doing it in two ways. The first one being straightforward, but has some boilerplate. And the second one being less straightforward with less boilerplate, requiring just a tiny bit more knowledge. And the method I'm going to show you, that the second one was introduced in Apollo Client 3. It wasn't available in previous versions. So let's go to exercise number 5. And I'm going to write these queries without explaining that much because we already did that. So I think that we should just write the queries. It's a good opportunity for you to train writing queries. You will be doing a lot while working with GraphQL. So again, and the steps we have to do is to pull in the messages. We will not be specifying parameters for simplicity and speed's sake, and also create a mutation that allows us to post a message. Again, we can generate stuff. Remember, we now can generate code. And then if time allows, I will show you both methods of updating the cache. If not, only one. And the second one is actually, I think, in the solution file. So you should find the second one there if we are out of time. So let's write our queries. So again, the same thing that you can create, though, that checklist that you have if you want to write queries, right? What kind of operation? Query. What's the name? Well, exercise 5 messages. And what kind of field? Messages. What do I want to pull? Well, ID for key list. When you are running list in React, you have to specify the key. And content. I don't care about creating that for the moment. So that's my query. Now, for the mutation, what kind of operation? Mutation. The name has to be different since, remember, we are now generating the types. The name has to be unique. So we have to put some thought into it. But usually the name, how you name the variable itself should guide you into creating a nice name for the query. So exercise 5 post message, for example, let's say. And it takes an input. Why? Well, I can get that information from the schema file or maybe from the playground itself. Maybe I'm playing around here and then switching back and forth. But basically what we want is this message type here. And we have to specify it here so that the parser that we are using here can update it, can validate it, right? And well, the name itself is message with an input of input basically. And yes, we can take ID, and yes, we can take content. But notice, you may be tempted to think, automatic updates, right? We have a key field, we have the type name, which is added automatically by Apollo client. Not so quite, because if you look at the queries, the message query returns just a message, and the messages query returns an array of messages. These structures are very, very different. Array is very different than an object, right? So, well, Apollo client is not that smart. I wish it was, but it's not. So we have to perform some manual work. Either way, let's start with generating code for these queries that we did. So what I'm going to do is go to the CodeGen file. There is a CodeGen YAML. And under there, wherever, also just one note, it allows for glob patterns. So I could write something like this, right? That's also work. What I'm not doing is, well, for encapsulation purposes, because I want to pollute imports with every possible generated type that I have in my application, right, from the each operation. So exercise, we are doing exercise 5. Now let's run the CodeGen. So this will generate types and operations, hooks, remember, blows my mind every time, for these operations. And the event says import generated hooks. So let's do that. So we have to now find the CodeGen, not exercise, final. CodeGen, yeah, there it is, and generated. And the naming, again, pretty strange, but it can be changed. Use exercise 5, extra, post, it's not there. Why is that? Because my TypeScript probably didn't pick up the change. So what I did is went Command Shift P and restart TypeScript server. That's sadly the beauty of Visual Code sometimes. Exercise 5. Oh, post message mutation. And why the name? Well, the name comes directly from the name here. And let's go with query. Use exercise 5 messages query. And there's a lot of query variations. There's also lazy query, again, pointing you to the documentation because, well, we cannot cover everything. So let's use them here. Const use exercise 4 messages query 5, sorry, with data loading error. And let's name them messages data and messages loading and messages error. Const use exercise post message mutation, right? And here, the function, remember, that's the function that will be performing the network request. So maybe post message. And we can go with loading. So posting message or post message loading to be consistent. Post message loading. Okay, so we have all the things here. Now we have to perform these, checks. If messages error, return message could not fetch, or better get messages. Fetch would be exposing maybe implementation details. I would rather avoid writing fetch at all. The name fetch, just something that I do. And what else? Well, if here doesn't matter. Okay, so if message is loading, return loading. Or not, of course, the optional check that I do. If not, messages data. Again, just to repeat myself maybe, but very important. I'm doing this check because TypeScript cannot know the correlation between loading state and the data state. And this is just I wouldn't call it a hack. It's just writing TypeScript. Performing a null check will always make the variable non-nullable or explicitly defined. So let's keep the comments for now. These are maybe for people who attempt to do it on their own. And let's write chat, just that. And messages will be, well, messages data, messages, yes. Again, everything typed due to type generation. Loading, well, let's go with false for now. And on message, well, let's go with empty function for now. And if I go to the exercise here, yeah, there we go. Messages are there. The form is not working, but we'll make it work. So function, async function, because we'll be performing a mutation. That's a network request. Handle on message. And the prop here is just a string. So message string. And again, I'm going to use try catch. It should be up to you how to handle errors. I didn't want to impose any kind of agenda. How do I would do that? If you're curious, you can look into candidate's profile source code. I'll be glad to link to that after the workshop. So await, post message, and well, variables. Now we are not sure. Well, TypeScript can guide us, or we can switch to the schema. But come on, switching to the schema when we have auto-generated types, much better auto-generated types than switching context, right? Input, content, that's and the message. Okay, so now we can copy this function to this handler, handle on message, and let's see. Let's validate our work. So message 2. It didn't get updated, just like we thought, but the message is here. That's a success. So again, it's not being automatically updated, even though we have the key field, even though the type name is implicitly defined by Apollo client. That's because the returned structures are very different. Apollo cannot be sure to tie this query with this mutation. It doesn't know the intent of the developer. It only knows types, right? So we have to help Apollo just a tiny bit more. So there's a special property called update. We have to specify a function. So what this will do is this allows us to basically look into the cache, interact with the cache, and the callback that we specify will take two things, cache and the data. And the data here is the data returned from our mutation. So we have a cache instance, and the data that was just returned from mutation, that's like a match in heaven, right? All we have to do now is basically update the cache. And by updating the cache, Apollo will notify every query that depends on the cache, on that particular cache piece. Again, there are sophisticated mechanisms built in the Apollo cache, and it will broadcast that and update our UI. So let's go with the most verbose way, and I think the easiest to understand way of updating the cache. So first of all, this is quite unfortunate. Again, not everything is perfect. We know that the data will be defined here, but the data has the null or undefined type because it guards us against something that is called optimistic updates. And this is an advanced, I wouldn't call it very advanced concept, but this is an advanced concept. And for our case here, all we have to do is perform a null check. In reality, performing this null check, if you are not using something like optimistic updates, will always be false because the data will always probably be defined, right? We are not returning null from the backend. We are returning a message. And this is guarded by the contract, by the schema types. Again, how do I know this? Well, let me go to the schema and I see that posting a message will get me a message back. Always the exclamation mark is there. So I will perform this null check only to satisfy the TypeScript compiler. And now our data, as you can see, is populated. I can get the data message. Now, how do I get the data from the cache? Because as I said, Apollo by default caches every operation. And if I use useQuery here, let me spacing, useQuery here, the data from this query, well, if I get here and this function is called, the chat was displayed, right? So the messages were displayed. So the data is in cache, presumably. So to write the data or read the data from the cache, there's a very simple method called read query. And we are going to be reading query from the cache. Again, TypeScript caches everything, even your operations. That's the name, read query, right? Because it cached query. So we can specify this query here as a parameter query, right? And well, let's name it messages in cache. But TypeScript, right. The read query is not automatically generated, right? It comes from the cache. As you can see, the type parameter is passed here, but it's quite unfortunate because the typings on the read query, sorry, are not that great. So we have to specify the query type manually. And again, we can use the auto-generated types. So exercise 5, messages query. That's the type which corresponds to everything I'm pulling here or in the query here. So it contains a definition of messages, array, and inside an object of messages, an object of message. So I know that I'm reading this query, and now TypeScript prevents me from making a huge mistake, not checking if the data returned from the cache is null. And you may be wondering, why is that? Why should I check if the data is in the cache? See, Apollo tries to preserve integrity when it comes to cache, because sometimes if you configure it wrong, like there may be a corruption in the cache. Something may be overwritten. Maybe you specified the cache properties in such a way unwillingly, but it's possible to really create a bit of havoc. And there is multiple warnings about this. Like if you develop, you will see warnings in your console. And if you see warnings about Apollo cache in your console, well, maybe I should try and tune in. Maybe I should add an ID here and there to make sure that cache will not overwrite anything or create any kind of corruption, because these things may happen. And from my experience, it never happened to me, like never. I've been using the Apollo client for a long amount of time. But in some rare occasions, like these edge cases, all you have to do now is perform a null check here and just return. Because, well, let's think about it. Do you really want to update a cache if it has integrity errors or integrity issues? In backend world, when we have integrity problems, you know what we do? We shut down our servers. We cut the power down, because having something with integrity errors running will result in more problems than actually benefits. So this is just a check, a sanity check, if you will, to prevent you from making really a mess. But that mess may never come, or it may come when you least expect it, if you really screw up. Usually you cannot screw up that much, but maybe you are trying to screw up or something like that. So, okay, so we have the messages in cache. And the messages in cache, well, they contain just what the query contains, right? The same here. Look, I'm going to to take the data from the query messages, the same signature basically, because again, the whole operation is cached, everything is cached by default. You can turn it off, there's no problem with that. So messages in cache. Now, how do you write to cache? Well, there is read query, and now we are going to perform a write query. Cache write query. And write query is just an alias. I just think of it as update query, really, because in this case, we are updating a query. You can write a query to like the query that never happened before to a cache to maybe pre-populate data in some occasions, like a prefetching, almost like a prefetching. But here we are really just updating a query. So there is no update query method, just write query. But don't worry, nothing will be overwritten. We have full control now. So the query is, well, the same query because we want to update the message query, right? And there is a data field. Now, just like the read query is not correctly typed, we have to do the same to write query. We have to tell it to which query I want to write. And you don't have to do that, but usually you would because it gives you type completion. So I have to sadly add the type names here manually. That may be a bit disappointing for you, but that's the most straightforward way. And yeah, that's I think it's good to have to do that because you get more insight. You can always, I will show you in a second, more concise way of doing it, but you'll see it's not that obvious. So again, just like in updating a state, you would never want to set state to like the non-new value. You have to create a new reference, right? So here I'm going to spread existing messages in cache messages, and then just append a new message. So the data message. And this is how I would go about updating cache manually. That's because, again, we are returning two different constructs. Imagine an API where you post a message and you get list of messages back. That's, in my opinion, that doesn't make any sense. So now, if we go and post a message, it gets updated. And we can validate that indeed it is working by looking at network request to make sure this is some like a sanity check. So what I should see here is just one GraphQL operation and probably an options request. So message for. See, there is one options request. So that's a course. And there is only one post message. But my list of messages got updated. This is cache in the working. Now we have 10 minutes left. We'll be not writing a test for this, but I really want to show you maybe, actually I will show you a third way, even more straightforward, but a way that comes at a cost. So you can delete the update function here. And there is a special property called, what's the property? Let me check. Update queries, refetch queries, yes. So imagine your cache is complex, or you are not feeling up to dealing with manual cache updates. Or maybe you want to mark the cache as stale, the query that got into cache as should be refetched on the next page entry, for example. And you don't know the cache contents of that query. You just want an escape hatch, easy way of marking something as stale. Because by default, Apollo, if you don't tell it otherwise, will not refetch your queries if you switch between pages, for example. Of course, it will do that if you do a full page refresh, but otherwise, it will not refetch the queries for you. So there is a property called refetch queries, and all I have to specify is just a query. So that means whenever you post a message, just mark the query as stale and refetch it from the database, from refetch it basically. So the query will be, well, I want update message query here. And there is a special property await refetch queries. That just means stay in the loading state as in mutation until this query is ready. It was fetched in the background and you can snap to a consistent UI state, because otherwise you would have mutation, right? It could have a delay, or it could, or no. Let's say a mutation computes in 100 milliseconds. So you have a mutation and the UI is ready, but the user doesn't see the new message, right? With await refetch queries, all that happens is that mutation stays in the loading state, so we can display a spinner, and in the background, Apollo will refetch, so basically perform the mutation again, or query again in the background, and whenever it's ready, the mutation state will flip from loading to false, and the query will be updated. So true. And now with this, again, this is an escape hatch. We'll be doing 2 requests. You can go to GraphQL here and message 5. And see, I'm doing 2 requests. That's an options. I'm doing post. Oh, sorry. Let me try again. That's completely message 5, 6. Okay, so I'm performing a mutation here. And notice that after that mutation, next query is fired. That's completely Apollo's client's doing. And the query is fetched again and updated. This is something I would recommend when you have a very, very 2 distinct, like distant queries, where one query, yeah, depends on another, but user will not probably go to that site immediately, right? So imagine, for example, having a background process which checks for the newest message while user is on some kind of other page, right? You may mark the query as to be refetched whenever a new message comes in, but the user is completely in a completely different in a different page. And the second way I told you that I will show you, well, I will just leave it to it because we have 6 minutes. It's included in the solutions file. I think it's this one. It's this one, yes, 01. As you can see, it's a bit less verbose, shorter, but definitely this cache notify and to reference, weird. I would stick with what I've showed you and get comfortable with the documentation. Then you can try to use cache modify and cache garbage collect, all that good stuff that comes with Apollo Client Free. And with that, I think we are done. We sadly didn't touch the authorization. That was the hardest part really, but I hope that the explanations on the application here for that exercise will be sufficient, and my solutions to get you through it. And if you have any kind of yeah, thank you. And if you have any kind of questions, please reach out to me. I'm happy to help, happy to talk, answer questions, anything like that.